In this lesson, we're going to learn how to find the distance between 2 points, or the length of a segment. So the first way that we can do this is by graphing the points and then using the Pythagorean theorem. So let's start off by just graphing the two given points. So we have -2, 1 and 4, 3. So 1, 2, 3, 4, up 1, 2, 3. And my goal here is to find the distance between these points, or the length of the segment that connects these points. So if I want to find the length of that segment, I can't just count it because it's diagonal. The only time that you can count on a graph is if it's vertical or horizontal segments. So for this, what I'm going to do instead is I'm going to create a right triangle out of it. Now there's really two options for right triangles. You could do one above it, or you could do one below it. Either way, you're forcing that diagonal to be the longest side, which means you're forcing it to be the hypotenuse. And then what happens is these other two legs you can just count because they're always going to be vertical or horizontal, because that's how you're making it. So the length here is going to be 2 units, and then the length down here is going to be 1, 2, 3, 4, 5, 6 units. So if I want to find the length of this purple segment here, so that's going to be my C, the first method I can do is use Pythagorean theorem. So I'm going to go ahead and write that. So method number 1 is really the graphical way of doing this. So that's going to be using a squared plus b squared equals c squared. So what we do is we go ahead and plug in. Remember, the legs don't matter, but c is the longest side. So that means I have 2 squared plus 6 squared equals c squared. So 2 squared is 4, plus 6 squared is 36, equals c squared. Combine those, so you get 40 equals c squared. Square root both sides. So you end up with plus or minus the square root of 40, but remember, we just want to keep the positive case because it is distance or length of a segment. And then think about if we can break this down. So the square root of 40 we can break down. So the biggest perfect square that goes into 40 is going to be 4. So 4 times 10 is going to give me 40. So square root of 4 becomes 2. So 2 square root of 10 is going to be our answer for that. So again, to check your work to make sure that you're getting the same answer, like if you're not sure about the simplifying, just type square root of 40 in your calculator, type 2 square root of 10 in your calculator, make sure you're getting the same decimal, and that's how you can verify that you did get the correct answer. So that's one way of finding the distance between 2 points. Whenever it's a diagonal line, you can't just count. You can just make a right triangle out of it and use Pythagorean theorem. Now, the downfall of only knowing this method is going to be what happens if they give you a coordinate like 30, 52 instead of 4, 3. Not something that you can do on a graph. So what we have instead, which is common in math, whenever we can't use a graph or something that we can just count, we have a formula. So a formula that will help us figure this out. So the formula is called the distance formula, since we're trying to find the distance. So method number 2 here is going to be using the distance formula. So distance formula, so it's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So essentially what it is, it's the change in x's squared plus the change in y's squared, all under the square root. This comes from the Pythagorean theorem, because the change in x's, when you subtract the x's, really what you're doing is you're finding that horizontal change. And then when you subtract the y values, you're finding the vertical change. So that's that y value that we found, or this vertical leg. And then if you think of it as the horizontal change, which is 6 squared, plus the vertical change, which is 2 squared, equals c squared, and then we end up square rooting it, which is how we end up with d equals the square root of the change in x is squared plus the change in y is squared. So to plug into that, just to practice using it, I always say start off with your template. So get your square root, get your parentheses squared plus parentheses squared, because that's coming from the Pythagorean theorem. And then let's go ahead and plug in our coordinates. So we're going to subtract the x values because you're finding the horizontal change. The order that you subtract these doesn't really matter because you're going to end up squaring them anyways. And you're really just finding the change in the x's. So I usually just go right to left. So 4 minus -2. Be careful with that -2 that you make sure you keep it. And then you're going to do the vertical change, which is the y values. So 3 minus 1. And then from here, you just simplify. So we get d equals, so simplify in parentheses first, so this becomes 6, which remember what we said, that horizontal change was 6, so here it is. And then the vertical change, subtracting the y values, was 2. So this is just the algebraic way of finding the legs of that right triangle if you were to use Pythagorean theorem. And it's because what happens when you don't have a graph or you get numbers that you can't graph, then that's when we use the formula. So from here, you should see that you get the same thing, 6 squared plus 2 squared. We had 6 squared plus 2 squared, so we get 36 plus 4 equals square root of 40, and then of course that's going to simplify the same way, so it'd be square root of 4 times square root of 10, because 4 is your biggest perfect square that goes into 40, or it's a factor of 40, so then we end up with 2 radical 10. So either way, you get the same answer. So that's the distance formula. So this last example here is using this whole idea of finding the distance or the length of a segment, but applying it to another situation, applying it to a quadrilateral situation. So first thing, if you don't remember what a rhombus is, a rhombus is a parallelogram that has 4 equal sides. So it almost looks like a slanted square in a way. So a rhombus has 4 equal sides. So if we graph this first, it'll kind of show you that it looks like it has 4 equal sides. So let's go ahead and graph it. So we have -2, 3, so 1, 2, 3. When you graph, it's very important that you're labeling your points. Otherwise, it's going to be a nightmare. You're not going to know which coordinate goes with which point. So it's just really helpful to label them up front as you're doing this. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's Q. Ours 4, 1, 1, 2, 3, 4. And then -1, 1, 2, 3, 4. So we connect these, and it should look as if these are equal, which to me it's looking like they're equal. Now I'm not using a straight edge, so mine aren't perfect. But you get the sense that these 4 sides are equal, which is what we're trying to show. So if we're trying to show that we have a rhombus, that means you need to find the length of all 4 sides, and they should be equal. So you're going to show the length of all 4 sides. Show the lengths of all 4 sides are equal. So I'm going to do 2 of each. So I'm going to do 2 with distance formula and 2 with Pythagorean theorem just to review each with you. When you're doing something like this, since there's 4 different sides, it's going to be really important to label which sides you're working with. So for this first part here, PQ, I'm going to start with. You can start with any of the 4 sides. I'm just choosing PQ. Notice how I'm labeling that I'm finding the distance between points P and Q. So I'm going to go ahead and start with my distance formula for this. So I'm starting with my template. And now I'm going to go ahead and plug in. So P and Q, so it's going to be subtract the x's. So 3 minus -2. And then subtract the y's. So 8 minus 3. And then we just simplify. So we end up with, so that adds, so we end up with 5 squared plus 5 squared. So we get 25 plus 25, which means we have the square root of 50, which if you break that down, that's going to be 25 times 2 is going to give me 50, so 5 radical 2 is what that reduces to. Then we move on to the next side, again, picking any side you want. I'm just going to go around in order here. So then the next side I'm going to work on is QR. So QR, going to subtract my x's, so 4 minus 3. And then subtract my y values, so 1 minus 8. Again, that order that you subtract doesn't matter because you're just finding the difference between them. You're just finding the distance, essentially, the vertical and horizontal change. So I have 1 squared plus negative 7 squared. And remember, whenever you square a negative, it should become positive because it's a negative times a negative, so it should end up being a positive number. So that's why these parentheses are super important to make sure that you're keeping those signs. So then I have 1 plus 49. At this stage here, once you've squared the numbers, you should never have negatives. So if you're looking at my numbers here, I never get negatives. So then I get the square root of 50, which we know breaks down to 5 radical 2. Because you have square root of 25 times square root of 2 becomes 5 radical 2. You do actually have to show all of this math. So even though we're trying to show it's a rhombus and all 4 sides should be the same, you do actually have to show it. That's what a proof is. You're showing that it actually is working out. So you're really proving that this is a rhombus. So now we move on to our S, and like I said, I'm going to switch over and use Pythagorean theorem just because I want to practice both ways with you. So to do Pythagorean theorem, we make a right triangle out of it. So 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So there's my right triangle. And then remember that's my C. So it's going to be 5 squared plus 5 squared equals C squared. And remember, you guys could do this all using distance or all using Pythagorean theorem. Your call, it's whatever you prefer. I just wanted to do a variety so that you could get used to both. So when I do this, I get the square root of 50 again. Again, breaks down to 25 and 2. So we know it's going to be 5 radical 2. So far, we're good. We're getting the same answers. Last side here that we have to look at is going to be ST. So go ahead and count that out. So it's 1, 2, 3, 4, 5, 6, 7, and then over 1. So there's my right triangle. So I have 7 squared plus 1 squared equals C squared, because remember now this is my C. So 49 plus 1 equals C squared. So you get 50 equals C squared. Square root both sides. We're only keeping the positive solution. So again, break that down. It's 25 and 2. So 5 radical 2. So then when I look at this, I see that I got all 4 sides are the same, so I just have to write a conclusion. Because it says show that it's a rhombus, I've shown mathematically that all 4 sides are the same, but now I have to actually summarize my findings. So the last step here is going to be just to write out our solution, basically, or write out our explanation. So we can just simply say, therefore, PQ RS is a rhombus because all four sides are congruent, meaning they have the same side lengths. So that's kind of as tough as it's going to get with distance formula, but remember you can use distance formula or you can use Pythagorean theorem. The only time you can't use Pythagorean theorem is if you run into a situation where you can't graph those points. That's where distance formula comes into play.